Good evening, students. Today we are going to discuss our practice paper 10. Okay, in this paper we have 12 MCQs to discuss. Okay, so now we have discussed up to electronic configuration in our theory class, and from chemical calculation lesson also we did a part of that. Okay, right. So today we have questions from every topic we discussed to revise what we learned earlier. So this is the paper we are going to discuss today. The first two questions are from, actually first three questions are from electronic configuration and quantum numbers, okay, which was our most recent topic. Okay, so let's start the discussion from the first one. You can see the question here. The number of unpaired electrons present in last energy level of nickel atom and then gaseous nickel 2 plus ion. Okay, so it's asking the electrons in last energy level. Right. So we learn about electronic configuration and quantum numbers. Okay. So once we know the atomic number of any given element, now we can write electronic configuration. So when we write electronic configuration, I hope you remember, we need three rules and principles. First one, we need Pauli's exclusion principle, which tells you that you can't add more than 2 electrons for a given orbital. Okay. And the other thing is the Aufbau principle, which tells you the ascending order of energy levels, sub-energy levels. Then you have to fill electrons in that particular order. First you have to start from 1s, then you have to go to 2s, then 2p, like that. It continues. Okay, in that order, remember, it says 4s is filled before 3d. That's the special point. Then we have Hund's principle. Okay, Hund's rule. Hund's rule is important when we were asked to draw orbital diagram. Other than that, it is manageable. We can write the configuration only with the first two things I said, Pauli's exclusion principle and Aufbau principle. Okay. So now in this question, we need the electronic configuration of nickel atom and nickel 2 plus ion. Okay. So now let's take their configuration. Okay. Right. So we need nickel. Its atomic number 28. So there is a small trick also. We can write the electronic configuration using this number. Remember, argon times 3d8 OS2. Okay, so this 8 comes here. Only for two elements this won't happen. Okay, for chromium and copper, because they show Aufbau deviations. For other elements, other 8 elements of D block, you can write the configuration in this. Okay, but this configuration is the condensed configuration, condensed electronic configuration. So if they ask for, let's say, if they ask for right electronic configuration, then don't write this one in an essay or structured essay paper. When they ask for the configuration, you have to give the full one. You have to start from all the way from 1s. Understood? Right. So if you write that electronic configuration, then you can write 1s2, 2s2, 2p6, 3s2 and 3p6. This is what we take as the argon configuration. Okay, then we can write the rest, 3d8 and 4s2. So even though 4s is filled before 3d, I ask you to write 4s outside. Okay, because for that, this kind of MCQs, right? Okay, so now what they are asking is how many unpaired electrons present in last energy level of nickel atom. Okay, last energy level. So what is the last energy level here? First of all, nickel atom. This is our last energy level. N equal 4 is the last energy level. Okay, N equal 4 is the last energy level. So if you just get the orbital diagram here, this 4s2, that 4s orbital is, there's one orbital that is completely filled, no? So do we see any unpaired electrons in last energy level? There is no unpaired electrons in here, no? Isn't it? So I'll explain what is unpaired electron in the when we are writing the nickel 2 plus. So however, in N equal 4 is the last energy level. So here, no unpaired electrons. No unpaired electrons. Okay, they are asking about the last energy level. Okay. And then you can write nickel 2 plus, nickel 2 plus. So nickel 2 plus. Okay, so now when you want to write the plus 2 cation, you have to remove 2 electrons. So where do we remove these 2 electrons? We should remove it from the outermost energy level. So what is the outermost energy level or outermost sub energy level is 4s, right? That's why we are writing 4s outside, right? So you have to remove these 2 electrons from 4s. Okay, so then what will be the electronic configuration? So remember, always when you are asked to write cation electronic configuration like this, write the element first, okay, then remove electrons. Okay, remember to follow that one. So now the configuration is this one. So electrons are removed from outermost sub energy level, outermost sub energy level. So now what is our last energy level? 3, third energy level, n equal 3 is the last energy level. Here is, okay, last energy level. So now here how many unpaired electrons will be there? So if you take this 3s2, it is just like this 4s2, no? It's fully completed. It's fully completed. You can draw if it is needed, just for explanation purpose, it is fully completed. And if you take 3p6, there are 3 orbitals and that also fully completed. So no unpaired electron. But you can take this 4d, sorry 3d. There are 5d orbitals. Okay, there are 5d orbitals. If you take them, then if you ask to fill like 8 electrons, according to Hund's rule, first of all, electrons are paired singly in a way that their spins are parallel. Then they will be paired like this. Understood? That's how we should show 8 electrons. And you can see, Lamai, there are 2 unpaired electrons. These electrons that are there with only one presence. Okay, there's only one electron here. So those are called as unpaired electrons. So there are 2 unpaired electrons. Okay, so what do we call these? These are called paired electrons. That's the difference. So what should be the answer? So at first you don't have any unpaired electrons in the last energy level, and in the when you get the nickel 2 plus, then you have 2 unpaired electrons. So your answer should be 0, 2. 0, 2. Answer is answer 3. Answer is answer 3. Understood that one, Lama? Is that clear? Okay, Lama. This is our second question. It's asking the set of quantum numbers associated with the last 2 electrons of an atom in an element are 31 minus 1 plus half and 310 plus half. So those are the 2 quantum sets of 2 electrons. So it is asking from us, what is this element? There are 5 answers given. You have to select the element from that answers. So you remember we did a similar MCQ in our theory class regarding, the element, the answer for that one was magnesium. Now let's see what about this one, right? So the 2 quantum sets are 3, 1 plus 1, 3, 1 minus 1 plus half, and the other one is 3, 1, 0 plus half. Okay, so they are the elements they have given: sodium, magnesium, aluminium, oxygen, and then sulfur. Those are the answers they have given. Okay, now here's the thing, right? So when you look at these quantum sets, okay, so there are 4 numbers, no, right? And it is telling you something, where the location of the electron, where the possible location of the electron. And finally, it says the spin of the electron also. So these 4 quantum numbers, N, L, Ml, and Ms, right? So if you take the first quantum numbers, Lamai, it is telling you the sub-energy level. It is telling you the sub-energy level. So if you take 3 and 1, so 3 means third main energy level, third main energy level, and 1 represents what? P sub-energy level. p sub energy level. Okay, so now it is telling you about 3p electrons. Okay, so final conclusion you can arrive here. So this element should have at least say 2 3p electrons. That is your conclusion. Now take the elements. Now they gave sodium. So what's the configuration of sodium? Now we can write the condensed configuration, because when you are doing explanations on and discussions, it is easy to write the condensed one. So atomic number 11. So condensed configuration is neon times 3s1, and magnesium neon times 3s2. So now these two can't be the answers, no, isn't it? Here the last electrons are belong to s sub energy. So they don't have p electrons. Understood? And then you can take aluminium. Its electronic configuration is 3s2 3p1. Okay, now there is a 3p electron, but there's only one 3p electron. Only one 3p electron. Therefore, this is also wrong, because we should have at least two, because both electrons are 3p. No? To understand the logic, because both electrons are 3p, right? And then you can't take oxygen also. It's actually you take oxygen 1s2 2s2 2p4, so you don't have any 3p electron. Therefore, it is also wrong. Okay, you can say no 3p electron. That's why it is wrong, right? And if you take now sulfur, this should be the answer, because that's the only remaining answer, right? Neon times 3s2 3p4. So now it has 4 3p electrons, right? 4 3p electrons. To just show it in the orbital diagrams, this is how it's there. Okay, so if you label them as -1 0 +1, now you can see what are these two electrons. If this is the 0th orbital, so the plus half, this electron, and then -1 plus half, these two electrons are the ones they have represented by the quantum set. Understood, Lamed? Therefore our answer will be answer 5. Sulfur is the answer. Now one of the students, when I put this paper, he asked that whether this should be silicon, whether this should be silicon. Okay, so my response was this can be silicon also. Why? Because our condition is what? It should have at least 2 3p electrons, right? So basically this element can be what? From 3p2 3p3 3p4 3p5 3p6, any element that can be included here. Okay, any element. So for example 3p2 will be silicon, then this one will be phosphorus, then sulfur, chlorine, argon. So all these elements can be possible answers, but out of those 5 elements only sulfur is given, so therefore we have to select sulfur. And you can see, Lama, these questions are a little better, no, better than the exam level. And these are the questions generally they ask in term test. Okay, somewhat moderate difficulty question. I'm not telling they are very hard. Okay, there are much better questions than this, but still you have to think a little bit, no, right? That's why. So practice them. So we did the past paper questions fully in the class, right? We have a good understanding regarding what is going to come to the exam, and it's better to practice something above than that. Okay, that's what we are doing here. Right, good. So the answer for the second question is answer 5. In our third question, it is asking if n represents main quantum number and L represents azimuthal quantum number, the maximum number of electrons that can exist according to the relationship. Okay, now they are giving us a relationship. N plus L should be lesser than or equal 4. So now this kind of MCQs is something totally another level. Understand, Naman? This is what I am telling as the hard level. Okay, so this question is not that difficult, can be done easily, right? But there's one question in our paper, in our tube. Did you see the last MCQ, the model question? As I remember, model question 3. Okay, so one of those model questions are included to this week's paper. You will receive that one this week, next week, right? And the last question I'm telling will be there for the paper 12. Okay, we'll discuss that also in this class, right? And this MCQ actually gives you the path and gives you the method about that good question, right? So we'll see how to do this question. Right. So it is n plus L lesser than or equal 4, right? First of all, it is asking how many electrons that satisfy this condition. How many electrons can satisfy this condition? That's what they're asking, right? So to get some idea, okay, we have to put the electronic configuration here. Okay, it's not about some element, just write the configuration as you understand. So it should be at least lesser than or equal 4, right? So then you have to give the electronic configuration at least up to 4th energy level. So don't write 5th energy level. It's not going to be useful, no? Why? Because n plus L should be lesser than or equal 4. So let's write only up to 4th energy level. That will be enough. So 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. If you want, you can write 4d10 also, no need. Like that, you can continue. Okay. So now the next step is making a table. Making a table. Study the method. Okay. This is the first time we are doing such a question. And then write here the n values. N value means what? The main energy level. So it is represented in the electronic configuration. It's not difficult to find. So here it is 1, 2, 2, 3, 3, 4, here. And those are the values. Okay. And then take L values. L value is the azimuthal quantum number. Azimuthal quantum number. Okay, now you need a little bit understanding here. If our sub-energy level is S, okay, then our L value is going to be 0. Remember? If our sub-energy level is P, if there are P orbitals, then L value is going to be 1. If it is D, it's going to be 2. F, it's going to be 3. Like that it continues. I hope you remember. Now here it is 1s now. So then it is going to be 0. Okay, like that continue. 0, 1. Here it is 2 because it is D sub energy level. Like this. Now what you have to do, just add them. N plus L. Now find the values for N plus L. Okay, N plus L. So here it is 1, 2, 3, 3, 4, 5. Okay, so that means 2 plus 3 is 5. You can't take this as an answer because our condition is what? Lesser than or equal 4. Lesser than equal or lesser than or equal 4. Here it is 4. 5 again, you can't take this. 6, you can't take this. Okay, so only eligible electrons are 4s2, 3p6, 3s2, 2p6, 2s2, and 1s2. So how many electrons are there? Huh? Here you have 2 electrons, 2 electrons, 6 electrons, 2 electrons, and another 6 electrons, and 2 electrons. So if you take the sum, right, here you have 10, and here you have another 10. So altogether you have 20 such electrons. Understood? 20 electrons that show this condition satisfied. Okay, so understand the method, Lama. So now give it a try about that last question I said in our atomic structure tube 3, the last page, we will find this question. Okay, HCl solution has a density of 1.42 gram per cubic centimeter. There is a HCl solution and it has a density 1.42 1.42 grams per cubic centimeter. Okay, and its mass percentage of HCl is 73%. Okay, and you are asked how much of volume is needed to prepare a solution of diluted HCl solution of 60 cubic centimeters with 1 mole per decimeter cube concentration. Okay, so that's the question. Right, so this type of a question, actually it was there in our separation and dilution tutor, but I couldn't discuss that theory with you in the class. Right, now let's see how to do that question in this one. So in this week, next week, I'm hoping to do that one in our physical class also. Right, but just get some idea, it's not that difficult, anybody can try. I know some of you might have done this question also really well. Okay, let's see. Right, so now here the difference is, okay, so it's not the concentration is not given. Instead of giving the concentration, what they have given us the density and the mass percentage. Okay, you have to understand these two data. But after that, now after you are finding the concentration, okay, that's our main target. Our first part is finding the concentration, and our second part is dilution. This is, I know most of you are very confident, and most of you can do this one also very well. Okay, and but the problem is the question is starting from finding the concentration. So we have to think about what is the method of finding this concentration. Okay, so I don't like to teach you fixed methods, Lamai. Just read through the data and try to understand the data. Okay, then you can do this one really well. Right, so what is this meaning of density? Density means what? Density is mass over volume. So now it is a solution. So we are here finding the density of the solution. So that means here we are taking the mass of solution divided by the volume of solution. That's what we are doing. Mass of solution is divided by the volume of solution. Here's the thing. Normally, what is the unit we express concentration? Concentration unit. So we are telling it in moles per decimeter cube. So here 1m means 1 mole per decimeter cube. So we always define concentration, usually, I mean, we define concentration using decimeter cube. We say how many moles are there of the solute in 1 decimeter cube of the solution. That's what the concentration means. Okay, so concentration means what? How many moles of solute present in 1 dm cube of solution. How many moles of solute present in 1 dm cube of solution? So Lamai, my point is this. We have to consider 1 dm cube of 1 decimeter cube of this solution. That's the starting point of the method. So what you have to do simply, okay, consider 1 dm cube of solution. Consider 1 dm cube of solution. Then find the mass of solution first. Find the mass of solution. So now we know the density now, and we know the volume to consider also. It is 1 dm cube. Okay, so what is the mass of solution? Okay, m equal dv, density into volume. Okay, 1.42 gram per cubic centimeter, and our volume is 1 dm cube. That means 10 to the power 3 centimeter cube. 10 to the power 3 centimeter cube. Okay, it gives you 1420 grams. 1420 grams. That is the mass of solution. That's the mass of solution. Okay, and then from that mass, that is the mass of solution. Okay, so then what is the 73? That data also we have to understand. What's the meaning of this 73? It says out of 100 grams, or you can say per 100 grams of solution, per 100 grams of solution, 73 grams is HCl, or in other words, you can say solute. Okay, telling solute is not that good, but however, let's say 73 grams is what? HCl. That's what the meaning of this one. So likewise, I am advising you to take the meaning of each data. So when they say density, it is the total mass over total volume. Okay, or we can say here it is a solution, therefore it is the mass of solution over mass of volume of solution. And when they give a percentage, that means how much of that is available. Okay, so the 100 grams of total thing, 73 is HCl. That's what it says. So now we found the total mass, no? Here, mass of the solution. Or in other words, you can say total. So then the next step is going to be finding the mass of HCl. So out of this 1420, 73% is HCl. This is the HCl grams. Okay, but now we can go to the last step. Okay, so we don't need the mass here, but we need the number of moles, because what is concentration? How many moles present in 1 DNA? Okay, so since we know the mass of HCl, we can simply convert it into moles. So moles of HCl is going to be what? The mass over molar mass. So 1420 into 73 over 100 is the gram. Okay, this is the mass actually. You have to divide that one. Dividing means multiplying by the reciprocal, no? HCl molar mass. HCl molar mass is 36.5. Okay, chlorine is 35.5. Hydrogen is 1. If you add them, 36.5. Okay, grams per mole. Then you will get the answer in moles. So what is the answer? What is the answer you're going to get? You can cut this one easily. Can you see? 36.5 to 73 you can cut 2 times. Okay, and then the zeros also cancel. So 28.4 moles. And then what is our concentration? Concentration of this solution? Concentration of HCl going to be 28.4 moles per decimeter cube. That's a very high concentration. So it's a very concentrated acid, highly concentrated acid. Okay, so we call them as commercial acids also. Why? Because that's what is sold by companies. Okay, that's what is being sold by companies. Commercial acids. So simply follow these 3 steps. That is my method. But you can still do this one by simply understanding the data. This is very, very special. And there was a MCQ in 2024 A-level question paper also. So I'm going to give you this one this week. Okay, so that means it will be discussed in our paper 11. Okay, so that is not the question they're asking. No? They're asking how much volume we should separate. Now it is simply dilution. Like I said, for dilution, we have a simple formula, because during dilution, number of moles are not going to change. Isn't it? Number of moles are not going to change. So what we can use is C1V1 equal C2V2 formula. We can use. Understood? C1V1 equal C2V2 formula. And here it is V1. So we know V2 and C2. So let's find out V1. V1 equal C2V2 over C1. C2V2 is 1 mole per decimeter cube into volume 60 centimeter cube. So if you apply in centimeter cube, I will get the answer also in centimeter. So my concentration is 28.4 moles per decimeter cube. Okay, so you can see if I simplified this one, what I have to simply do is division 60 by 28.4. It's something somewhere around 2 point something in centimeter cube. There's only one answer. 2.11 is there. That means our answer is going to be answer 3. Is that clear, Lamai? The method. So it's really important to understand the method of taking these steps. Okay. So we're going to practice several questions. So you have one in our online class now. You have the recording of this one. You can watch this one as much as times you want. And in next week theory class, right, we are going to try these questions also. So for Nugegoda students, I'm going to try one question tomorrow with you. Okay. And then in next week paper also, you will have a similar question. So we're going to repeat this one 3 times. I'm going to tell you the theory 3 times. Okay. You can study this one from that. Just understand, it's not that difficult. Can think. Just follow the 3 steps. Find in the total mass, then find HCl mass, then find HCl moles. That's it. Okay, 5th one. So there is a sample of alloy containing magnesium and aluminium. Magnesium and aluminium. It says their molar ratio is magnesium to aluminium molar ratio is 1:2. Okay. So first of all, let's say we have x moles of magnesium, then our aluminium should be 2x. That's what it is telling, no? 1:2. So let's point that one here. X moles, and this should be how many moles? 2x moles. 2x moles. Okay. Then it says we are reacting that one with 50 cubic centimeters of 0.4 hydrochloric acid. Okay. So this is being added to 50 cubic centimeters of 0.4 m HCl solution. And it says after ceasing the evolution of gas, that means 2 reactions are happening. Magnesium is going to react with this HCl. It's going to form magnesium chloride and hydrogen gas. So hydrogen gas is releasing, no? That's why it is says cease the evolution of gas. That means the reaction is completed. After stopping the evolution of gas, that means that the reaction is done. Okay. So to balance this one, we can use simply the inspection method, and you can put 2 there. Okay. So if we took x moles of magnesium, we will be needing 2x moles of HCl. No? Think about that too. Then take aluminium. Aluminium is actually an amphoteric metal, which means it can react both with acids and bases. Right? It's going to form AlCl3 and hydrogen gas. Okay, so to balance this one, we'll be needing like this. Okay, inspection method. Right? And if it is having 2x moles, now you can see we'll be needing 6x moles of HCl also. So altogether, how many HCl moles are spent? 8x moles are reacted. 8x moles are reacted. Is that clear, Lama? That part, right? And it says after the ceasing of evolution of gas, 60 cubic centimeters of this is reacted with 60 cubic centimeters of 0.2 m sodium hydroxide solution. Okay, so what is there to react with sodium hydroxide? Because that means some HCl should be remaining, no? That remaining HCl will react with this added NaOH. Okay, so we have to understand that also when we are reading this one, to react with remaining HCl. So from this data, we can find out how many HCl moles are remaining. Now it says in the question also, we're required to neutralize the remaining solution. It's asking the aluminium mass percentage. Aluminium percentage, mass percentage. That's what they ask. Okay, right. Now let's find out how many moles of sodium hydroxide actually added? Okay, so moles of NaOH. So we are using 0.2 mole per decimeter cube solution, and our volume is 60. 60 into 10 to the power minus 3 dm cube. dm cube. So answer is going to be 1.12 into 10 to the power minus 3 moles. 12 into 10 to the power minus 3 moles, right? That is the NaOH consumed. Okay, and that NaOH is reacting with HCl, no? And it is giving you this reaction, and they react in 1:1 ratio. So if you had 12 into 10 to the power minus 3 of NaOH, that means 12 into 10 to the power minus 3 of HCl remain. Okay, then we can find out added moles of HCl. So simply we can multiply that 0.4 mole per decimeter cube by the volume, 50 into 10 to the power minus 3. So you will be having 20 into 10 to the power minus 3 moles of HCl added. So out of that 20, you can see 12 into 10 to the power minus 3 is remaining. So finally, we can get reacted HCl moles. So from 20 into 10 to the power minus 3, we have to subtract 12 into 10 to the power minus 3. So what is the answer? 8 into 10 to the power minus 3 moles have reacted with this sample. Okay, which means Lamai, our 8x is equal to what? Our 8x here is equal to what? 8 into 10 to the power minus 3 moles, no? That's what it is telling. And then what is x? X is equal to 1 into 10 to the power minus 3. So aluminium moles will be 2x, no? 2x, no? So moles of aluminium will be 2 into 1 into 10 to the power minus 3. That means 2 into 10 to the power minus 3 moles of aluminium will be there. No? Then let's find the mass of aluminium. It's very simple. 2 into 10 to the power minus 3 moles into 27 grams per mole. 27 grams per mole. Okay? So that means 54 into 10 to the power minus 3 grams. Now, this is where you have to be very careful. When you are converting this into decimals, right? Be careful, right? It is 0.054 grams, not 0.54. Okay, so it's going to be answer 2. So those who got answer 5, they have done the question correctly, but they missed the decimal point. That's the problem. Okay, so I appreciate your effort, but be careful with the simplifications next time. Okay, right. So any doubts regarding the question? You have to think a little bit. A good question actually. Study the method. Okay. So about chemical calculations, Lamai, now this is our 10th paper, no? Some milestone of our journey, no? Isn't it? So that means we have done at least, let's say 30 chemical calculation questions. So now you have another task to do. I'll advise you on this thing in our next classes. Take a separate book and do these 30 chemical calculation questions again. Because you have the recording, no? Practice. I know chemical calculation is a little bit hard to grasp. That's why I started that from the day one, because you all will be better with more practice. Okay. So question number 6: the de Broglie wavelength that with an electron of kinetic energy E1 is lambda. Then it says the kinetic energy of this electron is changed to E2, same electron. Then its wavelength is 3 lambda. Okay, 3 lambda. So they are asking us the ratio between their kinetic energies, E1 over E2. That's what they are asking. What is this value? Okay, let's try the question. de Broglie wavelength, lambda equal H over mv. Now, here's the same electron, no? Same electron. So this mass is going to be constant. Same electron. and therefore we can say lambda is inversely proportional to the velocity. Okay, lambda is inversely proportional to the velocity. So now we can actually subject the velocity also. What is that? H over m lambda. H over m lambda. Right. Now if you write an expression for the E1, right? Half mv squared. Half mv squared. Half mv squared. Right. Now let's do something like this. Now let's say this is V1. So if it is 3 lambda, if it is changed to 3 lambda, then what is going to be our V2? H over m into 3 lambda. That is our second velocity. Okay, the next velocity. Now here you have V1. So we can substitute here. From this we can say E1 is equal to half m, then h over m 3 lambda, and that is our mv squared. Okay, I forgot that one. Yeah, square of this one. And then our second kinetic energy, again we can say half m, and now sorry, earlier it is m lambda, now it is going to be 3m lambda. 3m lambda, square of that. Okay, so like that I can take two expressions. So is there any doubt regarding this one for E1 and E2? Okay, E1 and E2, right? Then what they're asking is the ratio. No? That means you have to divide them. Okay, you have to divide them. So then you will get the answer. So when you are dividing, these values will be cancelled. Okay, so what's going to be there? E1 over E2 is equal to, H is going to get cancelled, lambda, m, everything will be cancelled. Okay, so here you will have 1 square. Here you will have 1 over 3 square. That means 1 over 3 square. Okay, so that means this 3 will come above 3 square. That means it's going to be 9. So 9 is the E1 over E2 ratio. And then you can do some elimination also here. You can do some elimination also by, because when we increase the wavelength, that means velocity is decreasing. When we increase the wavelength, that means velocity is decreasing. So when we decrease the velocity, kinetic energy is going to be high. Kinetic energy is going to be, when we like that, when we increase the wavelength by 3, you can say velocity is decreased by 3 times. Okay, so therefore this E2 is decreased by what? 9 times. Okay, you can simply think also without writing any lengthy formulae or anything, right? You can just think and get it. When you increase the wavelength by 3, velocity is decreased by 3 times. If velocity is decreasing by 3 times, because kinetic energy is directly proportional to the square of the velocity, no? So then our kinetic energy is also going to be decreased, but not by 3 times, but 9 times. Okay, but with 9 times. Like that you can understand. So E2 will be 9 times lesser than E1. So when you get the ratio between E1 and E2, you get the answer 9. It's very simple. You can think and get there also. Or you can write like I did. No issue. Okay, just try any method you prefer. Okay, no issue. So one of you asking whether we can write those chemical calculation activity I said, to take all those 30 chemical calculations separately. You can write them in your same book, Puta. That will be enough, because you have a book for the calculations now, the one you did. You can write the question also and then do the simplifications, because later you can study them. You can go through the questions once again. Like, there will be many uses, right? There are 2 years or more for your exam. You have to be ready from now on. Okay. Energy required to dissociate 1 mole of XX bonds. Okay, in gaseous state diatomic halogen, so don't worry about this gaseous state diatomic, those things. Okay. Anyway, you know, uh, this energy value is the important thing for us. It is 243 kilojoule of energy is required. Okay, it is asking the wavelength of photon that is required to break one bond. Okay, so this one is for 1 mole of bonds, right? So basically one photon breaks one bond. That concept you have to understand. Okay, one photon breaks one bond, right? So here this energy is for mole of bonds. So therefore here you have, this is the energy of what? 1 mole of photons. 1 mole of photons. We have a formula for energy of 1 mole of photons. Remember, we have this formula: E mole equal Hc over lambda into Avogadro constant. We can use this one to find the answer. Okay, so what we need is lambda, wavelength. So we can subject that one, Hc into Na, division energy of 1 mole. Then simply substitute 6.626 into 10 to the power minus 34 joule seconds. 3 into 10 to the power 8, this is the speed of light. And then Avogadro constant 6.022 into 10 to the power 23 per mole. And then divide this one. Energy of 1 mole of photons is 243 into 10 to the power 3 joules. Don't forget about the 10 to the power 3. Okay, it is kilojoule. And just ignore this unit here, because usually it is kilojoules per mole. Now they only have given kilojoule. Therefore, just add this unit also. Otherwise, answer will not come. Right? So we will get the answer in meters. Okay. You'll get the answer in meters. So you can separately take this 6.6, 3, and 6. Here 243. Because we are getting some approximate answer here. This is an MCQ. Here 10 to the power minus 34, 10 to the power 8, 23, and here another 10 to the power 3 is there. So you can simplify this one, 10 to the power 20, 28, and 10 to the power minus 6. This part gives you 10 to the power minus 6. Okay. Right, and what about this one? You can cut, no? 24 means 6 times somewhere around 40, like that, right? And 6.6 also you can cancel. 3.3, 20. So 3.3 into 3 is 9.9. 9.9 approximately 10. So 10 over 20 is 0.5. 0.5 into 10 to the power minus 6 meters. This is our approximate answer. Okay. So, but our answers are given in centimeters. See, centimeters. So, how do we convert meters into centimeters? We have to multiply meters by 100, isn't it? So, then this is going to be 0.5 into 10 to the power minus 6 into 10 to the power 2 centimeters. So, it's going to be approximately what? 5 into 10 to the power 20 minus 4, 10 to the power minus 5 centimeters. This is an approximate answer, and there is one very close to that one. It's only one answer actually with 10 to the power minus 5 cm. Okay, you don't need to actually, but anyway, you have to simplify at least by rounding off like I did. Understood that one, Lama? So your answer is going to be, actual answer will be 4.93 into 10 to the power minus 5. So the question number 8 answer is going to be answer 5. It's asking the correct statement. Now I'm going to tell you what to write, Lama. So write in front of answer 1 to 4 why they are incorrect. Okay, why they are incorrect. So let's first write about the first one, Balmer. Balmer series can be found in infrared region of electromagnetic radiation. That is wrong. Why? Because you find Balmer series in visible region. Okay, so you can write in front of that. Balmer is found in visible region. Visible region. And what do we find in infrared region? We find Partian, Fun, Bracket, those low energy series. Okay, so why the first one is wrong? Because Balmer is found in visible, not infrared. Then take the second answer. Alpha particles do not deflect in magnetic field. That is wrong. Why? Because any charged particle deflects in electrical and magnetic field. That was very first thing we learned in our class. Okay, any charged particle, write that sentence, exact sentence again. Any charged particle deflects in electrical and magnetic field. Okay, so saying do not deflect is wrong. It is deflecting, isn't it? It is deflecting. Yeah. When we say about Balmer series, Lama, earlier one, yeah, one of you, Yoshi, they reminded me that one. Very good. So we say Balmer series is partially visible, no? Isn't it? Because only 4 lines are visible, no? So the rest of the lines will be in which region? UV region. So when you're writing that, at that too. So you can say Balmer series is partially visible, 4 lines in visible, other lines in UV. Okay. Okay. Then third one, cathode rays do not deflect in electrical field. That also wrong because cathode rays are charged particles. No, cathode rays are basically electrons. So they are deflecting in electrical field. Okay, any charged particle deflects. Then fourth one also wrong. Why? E over M ratio depends for the positive rays, depend on the gas. If you take hydrogen gas, you will have a larger E over M ratio. But if you take another gas, then your E over M ratio will be low. Okay, so first, second, third, fourth are wrong. Understood? And about fifth one, these are gamma particles travel at the speed of light in a vacuum. So that one is correct. But yeah, one of you are suggesting whether that one is wrong also. Why? Because it says particles. Okay, but it is not wrong. Okay, we can say gamma waves, gamma rays, gamma radiations, fine. But according to Einstein theory, he said waves are behaving like particles, no lama, isn't it? So he called the particle of energy, he gave a name also, photon. We can say gamma particles means gamma photons. Understood? So using that word particle is not wrong. Understood? So therefore we can select fifth one as our answer. So anyway, Lamai, we are selecting the best answer here. Okay, so in A-level exam also in instructions, they are asking you to select the correct or most appropriate answer. That's why how they are asking you to do. So therefore, all other statements are clearly wrong. So when you are asked to select one, you have to go for the fifth one. Because in A-level exam, you have to mark some answer. No? You can't skip it. No? So answer for the question number 8 is going to be answer 5. So what about question number 9? It's an ABCD question. So can you all add the answer you got? It's asking which of the following transitions belong to the infrared region. Infrared region. Yeah, only A is correct, Lamai. Only A is correct. Infrared region means you have Partian and Fun in this infrared region. Okay. So Partian upper energy level to third energy level, fourth energy level, and fifth energy level. So you have to, the electron should come from upper energy level to third one, fourth one, and fifth one, like that. Okay, so those are the things belong to the infrared region, IR region. So if you take the first one, that transition is from n equal 5 to n equal 3. So it is belong in the Partian series. So this one is correct then. A is correct. But if you take B, that is n equal 4 to 2. n equal 4 to 2 is Balmer. Balmer is in visible region. Visible region. Actually, this color is green. 4 to 2. Remember? Then that one is wrong. You take C. That seems like an answer. N equal 3 to n equal 6. Right? But it is from 3 to 6. This is not emission. This is absorption. Absorption line. So it's not even an emission line. So don't even bother about this one. Okay. Absorption is not going to be the answer. And D, n equal 3 to 1. That is in Lyman series. So Lyman series is in UV region. So it's not, again, not going to be an answer. Okay. So like that, A is the only answer. So when you are selecting the answers in A-level exam, you have to select answer 5 because it is an other combination. If it is AB, you selecting 1, BC, you select 2, like that. No? So this is another combination, A only, you have to select answer 1. Answer 5, sorry. Answer 5. So what about the 10th one? The correct statement regarding electron. Electron tend to take a curved path in magnetic field. Yes, because it is charged particle. You can write in front of that because it is charged. According to Fleming's left-hand rule, charged particles will have a force on them when they travel through the magnetic field. Okay, so first one is correct. If it is charged, then it is curving in a magnetic field. And B, electrons have both particle and wave properties. That is 100% true. Remember last week in paper we had a good statement, no? Electron or other small particles show wave and particle properties simultaneously. Okay, if they say sometimes it is behaving like a wave, sometimes it is behaving like a particle, then that one is wrong. Okay, it is not going to behave sometimes. It is at the same time they show the both wave and particle properties. Okay, so this statement is anyway B here is correct. So A and B are correct. So what about the C and D? C and D are wrong here. So why C and D are wrong? Because look at C, addition of an electron to an atom or removing an electron from an atom cannot be done. It's wrong. So when we make ions, we add or remove electrons. So right in front of the answer C, this is wrong because when making ions, we add and remove electrons. To make cations, we can remove electrons. To make anions, we can add electrons. You saw that one in last week also when we write ion configurations, no? So C is wrong. Electron addition and removing can be done. Statement D, again wrong. Cathode ray, the speed of light is not seeing. Okay, cathode rays are electrons, no? So they will definitely have a lesser speed. Only photons traveling at the light speed, okay, in a vacuum. Only photons travel at the light speed at vacuum, write that one. Only photons travel at the light speed in a vacuum. Only photons travel at the light speed in a vacuum. So like that, question number 10, answer 1 and 2 are correct. C and D are wrong. What about this 11th question? The energy of 3D sub-energy level is less than that of 4P sub-energy level. It's asking about sub-energy level energies. So sub-energy level electron energies are arranged according to the Aufbau principle. Okay. So first 1s, then 2s, 2p, 3s, 3p, 3d, 4s, 4, yeah, sorry. Here am I, 4s is filled before 3d, 4s, and then 3d, like that. Then 4p, it continues. So if you are mixing up the order, okay, what you have to do? Just write in this way: 3s, 3p, 3d, 4s, 4p, 4d, 5s, like that. Then what I ask you here, you can put an arrow, two parallel arrows. Then you can draw other arrows also in a parallel way like for them. So now you can see after filling 3D, 4p is filled, no? That means 4p is having a higher energy. Higher energy. Higher energy. So that is correct. So our A statement, first statement is correct. What about the second statement? The value of n plus L for both of them, n plus L. That means if you take 3D, your n value is 3. Your L value is 2. Okay, so 3 plus 2, 5. Then if you take 4p, n value is 4, L value is 1. P sub energy level. So 4 plus 1, 5. So both of them have n plus L value 5. So second statement is also correct. But now you have to face the problem whether this second one can explain the first one. Okay, no. Why? Because to explain first one, you have to talk about the Aufbau principle, not about these quantum numbers. Understood? Therefore, our both statements are correct, but second one can't explain the first one. Okay? Because the explanation of the first one is Aufbau. Right? Write that too. So your answer is going to be answer 2. Now let's go to the last question, 12th one. The electron density distribution of 1s orbital of hydrogen atom is spherical. That is true, no? Because we know certain electrons will have certain shapes for their electron distributions. For example, any s orbital will have a spherical cloud. P orbitals will have dumbbell shaped clouds. D orbitals they have different shapes, right? Like that, for hydrogen, this statement is correct. But what about the second statement? According to Bohr model says electron is moving in a circular path, right? So that is also correct. The both statements are correct, but second one can't explain the first one. There is no explanation behind that. So what is the explanation of the first statement? The electron density of 1s orbital is spherical. There is actually you have to say regarding the probability cloud, no? Something like that. So there's not much explanation behind that, because the way we understand or way they decide it is a spherical distribution is actually from quantum theory, no? Quantum mechanics. We can't explain that further. But anyway, the theory comes from the quantum atomic model, that we can say. But telling it from the Bohr model, Bohr theory is a older one, okay, outdated one. So that is not going to be correct. Okay, so anyway, second one is also correct. First one correct, second one is also correct. But second one can't explain the first one. So your answer is going to be answer 2. Okay, for the 12th question also, answer is answer 2. So we did discuss 12 questions today, right? I hope you understand the discussion really well. And the first 6 questions I took some time and explained you, because those questions are really important. And the last few questions are basically asking about the the first theory part of the atom, about electrons and photons, then about this energy ascending order, descending order, like that. Those are some simple stuff, no? Emission spectrum, simple questions like that. That's why we took a small time to explain that one. But however, I hope you understand that really well, and write a good explanation, a review for this paper also, and keep them with your papers. And this is our 10th paper, so it's a good milestone for us in our journey, right? So let's do a lot of papers, right? So for 1 year, there are 52 weeks, right? So hopefully after 1 year, when we are transiting from practice papers to recap papers in a physical class, we'll be able to do more than 50 papers, right? So this is our 10th paper, right? This is the best thing you can do to improve yourself. So study well and good night, Lamai. So write a good review for this one, okay?